And this is x to the fifth. One more time, let me make sure. The cube root of x to the third inside plus 15x plus 4. Is that correct?
Yes.
Perfect.
X to the fifth outside.
And I put it in front because we normally don't write anything after the square root because we're afraid that we may extend the square root or the root on top of it. So that's why I'm going to put it in front. Is that okay? It's the same thing, right? 2 times 3 is 3 times 2. Good. So this is definitely the product rule that needs to be applied. So f prime of x, I differentiate the first function, I get 5x to the fourth, multiplied by the second function, which is the cube root of x to the third plus 15x plus 4, and then plus. I copy the first function, and I differentiate the second one. The second one is ugly because it's x to the third plus 15x plus 4, everything to 1 over 3. So remember what happens. It's a function to a power. So I have to bring the power down. So I will have 1 over 3 multiplied by x cubed plus 15x plus 4, 1/3 minus 1, which is negative 2/3. Let me write it for you here. 1 minus 1/3. Again, of course. I'm not used to writing this on the side. So 1/3 minus 1 is negative 2/3. Okay. And then multiplied by the inner function prime, which is 3x squared plus 15. I will have to rearrange it. So the first function is here, and now when I differentiate this one, I have 1/3 in front. I subtract 1 from the power. 1/3 minus 1 is negative 2/3 times the inner function prime, which is 3x squared plus 15. So I can't do much with this. So let's see what comes up. So this is the cube root of x to the third plus 15x plus 4, and then plus. X to the fifth is at the top. In parentheses, we have 3x squared plus 15. And this is a 3 in the denominator, and this will be the cube root of x to the third plus 15x plus 4 squared. Any questions so far? I don't know how far they want us to take it, but we will take it as far as we can. I'm going to try this and see if this is visible, because they are different. So the denominator is the only denominator I have, which is this. Is this visible, or is it's not thick enough?
It's fine. I can see it.
Okay, let me know if it's not good. Okay, so since this is the only denominator, is the least common denominator, so I have to multiply all this by 3 times the cube root of x to the third plus 15x plus 4 squared. So 3 times 5 is 15, x to the fourth. And when I multiply these two, I get the cube root of the inside to the third, so the cube root goes away. So this is x to the third plus 15x plus 4. And plus x to the fifth, 3x squared plus 15. Promising. Of course, I will factor out x to the fourth and then see what else I can do inside. It's a nice problem, actually. I don't know where it came from, but where you found it. I know Joseph gave it to us, but I don't, you know.
It was from my lab math.
It's a nice problem. So 3, the cube root, x cubed plus 15x plus 4, everything squared. So I will factor out x to the fourth. I want it out. Remember, factor, simplify, factor, simplify. This is the key. So this is out, so I distribute 15x to the third plus 225x and plus 60. So x to the fourth is out, so I'm distributing 15 to x to the third, 15 to 15x, 15 squared is 225, and 15 times 4 is 60. So now plus, x to the fourth is out, but I still have an x left in here. So x distributed to these two, plus 3x to the third, and plus 15x. And you know me, that's why I was thinking to write with a thinner marker. Maybe I can fit my writing in one line. Okay. Good. So yes, I'll combine like terms. So I have x to the fourth outside. These will make up 18. X to the third. This will make up a 240 x, and this will be plus 60 over 3 the cube root x to the third plus 15x plus 4 squared. And let's see, because I like to get rid of this 3, and I can yeah, even 6. Can I simplify by 6? Yes. By 12? No. So I can factor out a 6, and I get 3 x to the third plus 40x plus 10 over 3 times the cube root of x cubed plus 15x plus 4 squared. And at least I can get rid of something a little bit. So this is 2x to the fourth, 3x to the third plus 40x plus 10 over the cube root x cubed plus 15x plus 4, everything squared. I was thinking of banning Joseph from picking problems, but I think it was a wonderful problem. Thank you. I was kidding, of course.
Yeah, this problem gave me problems as well.
Is it clear now? Thank you so much for bringing it to class.
Yeah, it's clear. The way they showed the solution in MyLab Math was different.
In what way? I'm willing to learn. Is it a better way? Is it an easier way? Is it
So in MyLab Math, the derivative is 80x to the fifth plus 6x to the seventh plus 20x to the fourth, and that's the numerator. And the denominator is x cubed plus 15x plus 4 to the power of 2/3.
so can you give me the denominator is the same. So can you give me the numerator? I want to write it down. That's what they say. It's the correct answer, you mean?
Yeah.
Are you sure we copied the correct problem?
Yeah. The cube root of x to the third plus 15x plus 4 times x to the fifth.
Was x to the fifth inside the cube root, or was it outside?
It was outside.
Okay, so let me write the answer that they say it's correct.
So it says 80x to the fifth plus 6x to the seventh plus 20x to the fourth.
20x to the fourth.
Yes.
That's the numerator.
Yes.
And the denominator is this?
Yeah.
So, okay. So 2x to the fourth. I mean, we know how to do this, right? So, x to the fourth is out. If I factor out, what do I factor out? 2. So this is 40x. So to the fourth. So this is 3. Sorry. I have to put this one first. It's all over the place. It shouldn't be like that. It has to be in order. I disagree with this. So I take out 2x to the fourth from the first term, of course, in the descending order. So I get 3x to the third, done. The next in line is this. So I take 2 out and I get plus 40x. Done. And now the next one in line is I factor out 2 and I get plus 10. So there is absolutely no difference.
Okay.
It's absolutely the same thing. However, this is not correct. This is not arranged in the correct order. It doesn't follow the rules of factoring, and it's not ready for chapter 2. This is the correct answer. It's arranged in the correct order. It's in descending order. It's completely factored, and it's ready for chapter 2. This is a mess. It's not even in descending order. Very good. I love these discussions. Is this clear?
Yeah.
Perfect. You can enter it correctly or you can enter it like this. They will have to give you the points, but this is a mess. Good. Very good. Moving on. Anything else? Anything else for me? Anything else once? Anything else twice? Okay, so we start today applications of differentiation. It's not to say that if you 10 minutes from now you remember to work on a problem or you want to work on a problem, I'll stop and I'll work on that problem that you need help with, okay? So we have several applications of differentiation in this chapter, but one of them deals with graphing functions. And you can say, what? What is this? I can grab a calculator and graph a function, any function I want. True. Yes, we can do that. However, what we learned in chapter 1 will help us understand the graph of a function and how to graph it without a calculator. Do we have to do it without? No, no. You will see what am I talking about here. So before we even talk about graphing functions, we have to look at the very first item that is the most important one here at the beginning. It's called a critical number or critical numbers. I'm going to abbreviate to CN, so I don't have to write that again. So first of all, what is a critical number? And why is a critical number important? So item number 1, a function without critical number or critical numbers cannot have a max-min. Max or min or both. It cannot. However, a function with critical numbers still may or may not have a max or min. So what am I really saying? It is guaranteed that if it doesn't have a critical number, it will not have a max or min. Done. But if it has a max or min, there is no guarantee that that critical number will change into a max or min unless certain conditions are fulfilled. Unless certain conditions are fulfilled. So if it doesn't have a critical number, there is no way. We know for sure it has no max min. But if it has critical numbers, that's promising, but not a guarantee that it will have a max or min. Certain conditions have to be fulfilled. Okay. Number 2. What is a critical number and how do I get it? So critical numbers come from 2 possible sources. A function doesn't have to have a critical number. A function doesn't have to have a critical number. But if it has, it can have from one source or the other, or it can have from both. What are those sources? F prime of x is 0. Solving this equation will produce, if the equation has solutions, will produce critical numbers. Solutions will be, if they exist, critical numbers. And what is the second possibility, or the second source? And we have to check both for any function that we are studying. We have to check both sources. So the second source, which is here, is when f prime of x is undefined for x values, where f of x is defined. So what am I saying here? Sorry. So what am I saying here is this, that if this function, the derivative, happens to be undefined, let's say, for x equals 5, but the function is not defined at x equals 5, this is not a critical number. But if f prime is undefined at x equals 5, but the function exists, is defined at 5, then x equals 5 becomes a critical number. If both functions are undefined at 5, 5 is not a critical number. Okay, and now you're going to see what we do with the critical numbers. Of course, what am I going to do? Find max min if they exist. So let's look at a few functions. Let me see where I'm with the time, 17 minutes. Let me stop that.